Welcome everyone. My name's Michael Downey and I'd just like to welcome you to today's webinar on hot extraction, a tool to manage compressed vintages. I'd also like to welcome today's presenter, Simon Nordestgaard, a senior engineer at the Australian Wine Research Institute. Simon has a long history working in the wine sector and has a PhD in chemical engineering from the University of Adelaide. He has spent the last 6 odd years at the AWRI working on a diverse range of projects relating to wine production. In today's webinar, he'll be discussing hot extraction, an alternative approach to conventional red fermentation to help combat increasingly compressed vintages. Before I hand over to Simon to get us started though, a couple of quick notes on what to expect for those that are new to AWRI webinars. The format is a short PowerPoint presentation followed by a Q&A. We do encourage attendees to get involved and interact. So to ask a question, please type into the questions pane of your control panel in the bottom right corner of your screen. For those with access to a microphone or anyone that's dialed in on the telephone, there's also the option of speaking with us directly by clicking the raise hand button, which is located in the top left section of your control panel. Questions will be answered at the end of the session, but please feel free to send your questions through at any stage. Okay, I'll hand over to Simon now to get us started.
Okay, thanks Michael, and thanks everybody for attending. So I guess as Michael said, I'm going to talk a bit today about the hot extraction in red wine production. It's something that I've taken a bit of interest in learning a bit about over the last year or so, and I'm going to give a bit of a summary on the topic. First, I'm going to go through some of the basic principles. I'm then going to briefly cover some of the history of the technique, which will lead into some discussions on the different equipment that has been and is used. I'm going to talk about some of the effects of different process conditions like time, temperature and clarification. I'll then discuss some supplementary techniques that have been developed to enhance performance, and then I'm going to talk about the impact of hot extraction on pyrazines and whether flash dateon is a possible treatment for smoke-tainted grapes. I'll then end with a few conclusions. So basically, hot extraction is heating red grapes before ferment to speed up the extraction of colour from the skins. Grapes are heated to somewhere between 50 and 90 degrees and then held at an elevated temperature for somewhere between a minute and 12 hours. After that, you can press and do a liquid phase ferment of the now red juice like you would do when you were making a white wine. Alternatively, after cooling, you can perform some period of solid phase ferment on skins, just like for a normal red wine ferment. There are many process variations. I've used the generic term hot extraction as a bit of a catch-all. Thermovinification is another term that is sometimes also used as a catch-all, but I haven't done this because in France the term thermovinification tends to be reserved for treatments where the hot maceration time is less than an hour and a liquid phase ferment is performed. When a longer period of maceration is used, they call it pre-fermentation hot maceration, or MPC, the acronym for pre-fermentation hot maceration in French. Hot extraction has been and is used for a number of reasons. These include to reduce production costs by allowing red ferments to be performed like white ferments in more basic tanks, and I guess that's the main tie-in with managing compressed vintages. It's also been used to destroy lactase enzymes in rotten grapes, to remove green aromas, and also as a tool to produce wines of different styles than possible with traditional red wine fermentations. Hot extraction as a tool is, I guess, hardly used in Australia at the moment. This is not the case overseas. For example, in France, around 500 million litres of wine are made with variants of this technique each year. It's not just France either. It appears that it's used in many large wineries in other parts of of Europe, Spain, Germany, Italy, as well as in South Africa and South America, and to a smaller extent in North America. Heating grapes is not a new concept. I guess in the 18th century, Maupin, an author of several winemaking texts, talks about boiling a portion of grapes before fermentation. He also says that the amount should be varied depending on the weather, which I guess alludes to the condition of the grapes. In the 19th century, there were some issues in Burgundy with producers adulterating wines with the synthetic aniline dye fuchsine. Prunier writes a book describing a range of natural alternatives that wine producers can use to get better colour, one of which is pre-fermentation heating. I guess in 1906 in California, there was also interest in pre-fermentation hot extraction. Bialetti writes this report entitled A New Method of Making Dry Red Wine. The heating apparatus they use is on the cover. Consists of a system of copper tubes in which juice flows and is heated by steam. What they did is they crushed, destemmed and drained the red grapes. They heated the juice up and put it back into a tank with the skins. After they were happy with the amount of colour, they drained off the juice again and performed a liquid phase ferment. Like most old reports on hot extraction, they're very, very positive about the quality of the wine produced. Before the 1920s, people always had crushed grapes before heating them. In Burgundy, Ferrer took a different approach. He wanted to keep the grapes whole, heat them up, let the colour from the skins diffuse inwards, and then crush, destem and press the grapes. In this implementation I've got on this slide, built by one of his collaborators, there's hoppers that are filled with grapes. A quantity of juice is boiled and added to the grapes. After 4 to 5 minutes immersed in the hot juice, the juice is drained off. The drums the pivoting drums are tipped into small vessels, and the hot grapes are left for 12 to 24 hours of contact before processing. The juice is in this device. The juice is reheated, and the process is repeated for drum load after drum load. And there are two sides, so it's a semi-continuous process. Ferrer was an advocate of hot extraction, but it doesn't seem like there was a huge amount of commercial adoption of the technique at this stage. This sort of changed in the 1960s and 70s. There were some disastrous vintages in France that in 1960s with widespread rot, particularly in 1963, and people were interested in ways to manage this. High throughput continuous equipment was developed that was able to rapidly heat large quantity of grapes, managing lacase and allowing for production of red wine relatively cheaply. And lots of French and Italian equipment companies developed packaged processes at this time. I guess coming back to Australia, Europe wasn't alone in its interest in thermovinification. In 1973 in Australia, Bryce Rankin described it as one of the most important recent developments in Australian winemaking. The second Australian Wine Industry Technical Conference, and also in 1973 there were 2 plenary speeches on heat extraction by Gunter Prass and by Kolarovich. Gunter Prass reported on Orlando Wine's trials using thermovinification to make both red table and fortified wines. He included evaluations of the technique by a winemaker, a technician and a winery manager. The winemaker basically said that you're kidding yourself if you're trying to make a traditional wine with thermovinification, but if you want to make different wine styles, it has a place. The technician liked it because the heat kills microorganisms and throughput was higher. The winery manager also liked it because of the production efficiencies. Prass finished by saying that he believed that thermovinification has a definite place in the technology of winemaking in Australia. So I'm going to go through a few of the systems that were used at that time and how they've evolved to the present day. One of the thermovinification processes that was developed around the time was the Gasquet process, which used a scraped surface heat exchanger. I've got a process flow sheet here from a 1981 paper by Wagner. So basically the grapes are partially dejuiced in a tank. The dejuiced grapes and then pumped through a scraped surface heat exchanger. So I zoom in on that heat exchanger to show how it works. Basically, the pre-drained grape skins go in, steam goes in on the other side of the heat exchanger, a paddle rotates in the skins to improve heat transfer, hot grape solids come out. After the hot grape solids then go into a holding tank to provide a period of hot contact before partial cooling and then draining in a continuous incline drainer and pressing in a continuous press before further cooling. Scraped surface heat exchangers are still used for hot extraction. Here's a picture of a modern implementation. Another thermovinification process that was developed by Immersion, which relies on immersion for heating. Again, I have this process flow sheet from the 1981 paper by Wagner. There is after the grapes enter there's a pre-draining device. Then the pre-drained grape solids pass to the heating unit. And so if I zoom in on the heating unit, again, basically the pre-drained grape solids enter the device, and some of the juice, the drained juice that has been heated up, is sprayed back over the grape solids to heat them up. The hot grape solids exit, and the juice goes back to reheating. So going back to the main process flow sheet, after the heating, there's a holding unit also with a screw there that provides some contact, followed by a continuous incline drainer and press. Immersion further developed the immersion process over time. In 1991, they introduced the Thermo compact. This combines draining, heating and holding stages in a single smaller footprint unit. The whole or crushed grapes enter at the top where there are draining grills, and the rosé juice is drawn off. The pre-drained grapes then fall into the immersion heating system where they heat in a bath with the hot grape juice. They're conveyed through the bath using rotating chain rakes. The hot grapes then drained again and passed to a maceration tank section of this unit, which provides for some further hot maceration time. In the 2000s, the latest generation of immersion technologies came out. I've got here images of the Parapolenc Gulfstream and the Delatoffler Biothermo processes. They use the same general principles. The Parapolenc system is an open bath with the pre-drainer built in. The Delatoffler system has tubes back and forth and then goes out into the separator. Looking at the Gulfstream process, basically the whole of crushed grapes pass across a tangential draining screen. The drained grapes then fall into a hot juice bath in which they're conveyed along a track. They're being heated as they go in that hot bath. At the end, there's another draining screen that drains the hot juice, and the hot grape solids pass out ready for pressing or further pre-fermentation maceration. But I guess the Gulfstream with the tangential pre-draining is apparently a bit gentler on the grapes than the earlier Immersion immersion systems. There's some good videos on YouTube that show how this works. I would have included one here, but they don't work that well in the webinar format. So that might be something that's worth having a look at. Another continuous heating technique that is a bit different to the others is one that seems to be used quite a bit in Germany. And again, different to the others, it appears to incorporate heat recovery, and also different to the others, which basically involve a single heating stage or heating to a single temperature and holding for a period. It incorporates two different temperatures: a short period of hot contact at a high temperature around 8 degrees, followed sometimes by a longer period of hot contact at a warm temperature around 40 degrees. So firstly, how this works is the cold must is preheated using the hot exiting must, say roughly from 10 degrees up to 45 degrees. and then in the second stage, it's heated up to say 82 degrees with using steam. Then passes through some pipe work that provides a couple of minutes of hot contact, and then it's exchanged to provide that preheating effect with the incoming cold must, and then the must can then be held for several hours if desired at the sort of around 40 degrees to provide further warm contact before pressing. I guess in this arrangement you don't have to worry about lacquer during this period at 40 degrees or so, because the time at the very hot temperature, about 80 degrees, was enough to destroy the lacquers. Enzymes that can assist in pressing and clarification are also very active at this 40 degrees. I guess when you're using a tube-in-tube heat exchanger, I guess you might be worried about blockages, but they seem to have worked out ways to avoid this. I guess firstly, they aren't doing a lot of pre-draining like in the other processes that I discussed. Secondly, they're keeping the feed tank very well mixed and homogeneous. And finally, while they're using a tube-in-tube heat exchanger, the round examples I've got at the top of for the higher on the screen there, for the final heating step, with the steam in the annulus. For the preheating step, they're exchanging heat between two must streams. They tend to use heat exchangers with rectangular channels, so must doesn't have to flow through an annulus that could block. So all the modern systems I've talked about so far have really been focused on high throughput continuous production. Another method that is apparently used is batch heating, where juice is drained from a tank fitted with draining screens, and then it's heated up and put back into the same tank for as long as required. This is a relatively simple process, but the temperature rise is slower and more heterogeneous. So there are a range of different heating processes and systems in use. It seems like there are some quite strong regional and national differences. For example, in French technical references, they don't even mention the techniques used in Germany and vice versa. In the table here, I've tried to provide a basic general comparison of some of the continuous high throughput systems with their different performance characteristics as I sort of expect them. I guess with regards to speed and accuracy of heating, immersion is very good, and the two-stage process is also good. This great surface heat exchanger is not quite as good. With regards to needing to pre-crush, for the two-stage process, it's crushing is critical, because if you're going to avoid blockages, it's going to be reasonably important for the scrape surface heat exchanger to avoid blockages, but the device itself might perform some degree of crushing anyway. For immersion, crushing's not critical, because the material is being conveyed in a separate juice loop. With regards to pre-draining, you can't do that with the two-stage process because you risk blockages again. You can do some pre-draining with the scrape surface heat exchanger. With the immersion heat exchange process, you can do as much draining as you want, because the material is being conveyed again by that separate juice loop. Extensive pre-draining can be advantageous if you make a lot of rosé, and I guess it's also advantageous from the perspective of energy savings by minimising the amount of material that you're heating up and cooling down. Must homogenization is again important to avoid blockages in the two-stage system. The labour requirements for the immersion system are higher than for the other systems. The two-stage system is the simplest. Probably the simplest. There are no moving parts. The immersion system is going to be more difficult to clean. That two-stage process allows for heat recovery. So there's a few sort of general, I guess, pros and cons of some of these systems as I'd see them. So moving on to some of the specific process conditions that are used in hot maceration. Firstly, the maceration temperature. This plot shows the coloured anthocyanin concentration and colour intensity after 15 minutes at different temperatures. So basically you need to get above 40 degrees before the colour extraction really takes off, and over about 65 degrees it's very good. If we look at the issue of lacases in the harvest, as you're warming up the grapes, lacase activity actually increases, peaking at around 40 to 50 degrees. So if you've got lacase issues, you really need to really quickly get past those temperatures to temperatures where the lacase is actually destroyed. On temperature, you don't want to go too hot for too long, because it's been reported that longer periods over 80 degrees can lead to some cooked flavours. In France, the typical maceration temperatures that are used tend to be 65 to 85 degrees. If we look specifically at the issue of lacase destruction, I've taken a plot here from Roger Bolton's textbook that shows the time for destruction of 95% of the activity of lacase and also of normal grape polyphenol oxidase at different temperatures. So if we take a temperature that might be used in hot extraction of 70 degrees for lacase, it takes less than a second to destroy 95% of the lacase activity, and about 5 minutes to destroy 95% of the grape polyphenol oxidase activity. So looking at another obvious process condition is the maceration time, the hot maceration time. Anthocyanins are extracted much more quickly than tannins, and without tannins to stabilise the anthocyanins, without tannins to stabilise them, the anthocyanins, the colour is a bit unstable. With traditional thermovinification, contact times are only around 30 minutes, and this isn't long enough for enough tannin extraction to stabilise them. And it also means that the wines don't, the lack of tannin also means they don't have a lot of structure. In France, hot maceration times of 3 to 6 hours are apparently now common to try and get enough tannin to stabilise the colour without too much tannic aggressiveness. These are all, of course, all generalisations. The grape variety and desired wine styles have major influences on the process conditions that are used. I guess other levers available to control wine style, the level of clarification and ferment temperature. This is referring to when we're doing liquid phase ferments. Thorough clarification to sort of less than 100 NTU favours production of fermentation esters, while with less thorough clarification favours wines with more weight. Clarification of hot extracted juices is actually very difficult because there are a lot of small particles that have been released by the process, and furthermore the natural grape enzymes that that might break down pectinases and stuff have been destroyed by the heating process. So enzymes need to be added and to manage this, to manage clarification, and manufacturers do offer enzymes specifically targeted at hot extraction. Fermentation temperature also has an impact on the wine. Low temperatures favour esters, warmer temperatures favour riper fruit. For clarification, several different technologies are used. Rotary drum vacuum filtration has long been used. This results in a very thorough clarification, which does prevent some fining out of colour, but in conjunction with low fermentation temperatures, this does lead to lots of fermentation esters, and I guess this has contributed to thermovinification sometimes having a reputation for producing standardised wines with sort of almost banana or strawberry yogurt characteristics. With longer hot contact times being used, there's more tannin to stable anthocyanins, so there's not such a need to clarify as thoroughly as there might have been before. So there is the ability to use other clarification technologies that might move the wine profile from the typical thermovinification wines if that's desired. So I guess an extreme case of this, wines are sometimes made with with liquid phase ferments, but without any clarification between pressing and fermentation. So there's lots of, so looking at these time, temperature, clarification, so there's lots of different processes, parameters that can be manipulated to try and influence wine style. This is a table from the French Institute of Vine and Wine with some I guess some generalizations on the sensory characteristics of thermovinification wines and wines made by MPC with longer periods of pre-fermentation hot contact time, and then with liquid phase or solid phase ferments. I guess you have to bear in mind that these are subject to manipulation of some of the process parameters I discussed. But generally, thermovinification wines, they typically have estuary. They're more likely to have estuary characteristics. Little body and not very stable colour. Tannin addition can help with that. With longer periods of contact, the aroma moves away from the estuary profile. And with liquid phase ferments, after some pre-fermentation hot maceration, the balance starts to approach that of a classic red. With if you after some pre-fermentation hot maceration for solid phase ferments, can be lots of tannin and sweetness, and aging can be important for these wines. I mean, they're often used in blends. I guess one thing to note on that, I guess often some of these technologies can produce wines with diverse characteristics, and they might just be useful as components to bring certain characteristics to blends in large wineries. So I've talked a bit about the move away from thermovinification with short periods of hot pre-fermentation skin contact to longer periods of pre-fermentation skin contact to try and get more structure and colour stability. I guess another approach to this issue has been to use another supplementary technique on the heated must that further permeabilizes skin cells and enhances extraction. The best example of this is flash dateon. Flash dateon was patented by INRA, the French National Agricultural Research Agency, in 1993. How this works is that you drain and heat up the grapes like normal, but to a bit higher temperature, so it's near boiling. Then you expose the hot grapes to a vacuum in a big vacuum chamber, and some of the liquid that was near boiling then flashes. It boils immediately. This has a number of effects. Firstly, it cools the solids, so you don't need to use refrigeration to do that anymore. Secondly, there's this instant expansion of liquid, some from inside the skin cells. I guess as an indicator, a kilogram of material going in at atmospheric pressure occupies about a litre of space. A kilogram of the flash steam occupies 28,000 litres at 5 kPa. So the outcome of this massive expansion is the increased skin permeability and enhanced extractability of tannins and polysaccharides. You can see from this microscopy by Agaron and colleagues that they're more lacerations on the skins. Just finally, some with flash dateon, some volatile components like pyrazines are flashed off. This is condensed, and you can add it back or not if you want to the original grapes. You could put it. You can put it through activated carbon if you like before adding it back. With flash dateon, you can press and do a liquid phase ferment, or you can have some period of fermentation on skins if you desire. There are a number of brands making similar sorts of equipment. There's the Parapalank flash dateon, and there are other brands like the Delatoffler thermocooler and the Padawan Red Hunter. Flash dateon has also evolved a bit since its initial introduction. Sometimes only a semi-flash is performed. The idea is to use a slightly weaker vacuum, so you may only cool to, say, 55 degrees instead of down to 30 degrees at the outlet from the vacuum chamber. At this 55 degrees, you can add enzymes to assist with extraction, and the enzymes are very active at these temperatures. You don't have to worry about lacase because this was denatured by heating before flashing, and the yeast won't grow much at 55 degrees, and you can even do this short maceration stage where you're filling a large membrane press. Some of these concepts are actually quite similar to the two-stage German hot maceration process I mentioned earlier, with that second stage of maceration at the sort of intermediate temperature after a prior much higher temperature. Another technique that has been used to try and enhance heating post-ferment is the thermo-dateon process, now being sold by Book of Aslan as extractus. In this technique, after heating, grapes enter bottles which are pressurized to 100 to 400 kPa above atmospheric pressure. The pressure is then released, and the grapes pass into a maceration vessel. It is a different technique to flash dateon because there's no phase change. Inlet some of the liquid flashing to steam, so you don't have that evaporative flash expansion of fluid from the skin cells, but there is some apparent smaller effect on extractability. I guess it seems to be being marketed as a technique that can be integrated into existing thermovinification chains in wineries. So pre-fermentation heating also has some ability to remove green characters. I've got some data here that I've taken from 3 different papers relating to the removal of pyrazines, of the pyrazine IBMP. This compound's sometimes described as having green capsicum, herbaceous and tomato leaf characters. It's got a boiling point of 50 degrees. The first study I have here on the left of screen is for Cabernet Sauvignon that's been made with thermovinification or traditional production, and it shows that the IBMP levels are lower for these 5 wines than traditional production. The second study similarly shows that MPC gave lower levels than traditional production for Fur Cervado. And then the third study shows the effect of flash dateon on IBMP levels in the grapes and the juice from the flash dateon process for Merlot and Cabernet Sauvignon. And again, there's a much lower IBMP levels in the processed juice by flash dateon. I guess in addition to pyrazines, some C6 compounds can also cause green characters, and they're also lower in hot extracted grapes, mainly because the enzymes related to their production are damaged by heating. Flash dateon has also been reported as a possible treatment for smoke-tainted grapes. Dobson presented data for Pinot Noir that had been smoke affected and wine made with traditional methods or flash détente with a solid phase ferment. The smoke taint marker compounds were lower in the flash détente treated wines produced with flash détente versus in the control wines. I guess in evaluating smoke taint treatments, we have to be a little bit careful because sometimes smoke taint can return. The reason being that the compounds responsible for the smoky characteristics are bound to glycosides with no aroma, and the free aroma active compounds can be released from the glycosides over time. Nevertheless, it's an encouraging result, and I think there's further studies should be performed on the application of smoke taint of flash détente for treating smoke affected grapes. Perhaps other process steps may be needed, such as treatment with glycosidases. So coming back to the title of my presentation, is hot extraction a tool that could be useful to manage compressed vintages? Well, I think the answer is yes. Less time's required on skins, so you can get things through faster. Of course, there's be some significant investment in new heating equipment, possibly cooling equipment as well, and that'd have to be justified, possibly against avoiding investment in additional fermenter capacity or labour cost savings. Because there's lots of different bits of equipment available, and the cost varies a lot. So if people go down the path of hot extraction, they have to work out what's right for them. There's things like flash détente are more expensive, but you're also getting a more sophisticated tool that gives you a bit more flexibility in tailoring your product than you get with some of the more basic equipment. So it's a balance. I guess the more you spend, the more sophisticated the equipment you get. So in summary, on the topic of hot extraction, I'd say the concept's old, but understanding and techniques have evolved through research and experience. There are many different process settings, and a variety of outcomes can be achieved. Hot extraction is never going to replace traditional red wine making, and I don't think you'd want it to, but it's another tool that may be useful for some wineries to produce different styles, manage higher grape throughput, and manage variable grape composition. I'd like to quickly just thank the various equipment suppliers I've mentioned who've provided information on how their equipment works. I'd also like to just acknowledge the French National Agricultural Research Agency, INRA, and the French Institute of Vine and Wine. I've got a lot of the information for this presentation from this web link I've got here. It's really quite practical information at that link. I guess these agencies have performed a large amount of work on the topic of hot extraction over the years, and there's a great deal of information on the internet from their work that I've drawn on. So I just like to end by thanking people for attending. I do plan to write an industry magazine article in a couple of months that will probably cover a lot of the material in this presentation, as well as probably a few other aspects of hot extraction and practicalities of implementing these techniques based on some further investigations I'm making at the moment. Thank you.